this piece of pie called? Sector. What's this thing called? Arc. Arc AB, and you put the arc symbol. And it's what kind of arc? You don't know what I'm talking about there. That's a minor arc. And if you go a long way around, arc ACB is a major arc. And if you do like arc BAD, bad, it's a semicircle. And what's the relationship between this angle right here and the arc's measure? They're the same. But sometimes we didn't find the measurement of the arc like in degrees, we found the arc length like in inches or something. How did we do that?
2 radius times 5 times the degrees of the distance.
Yeah, starting to sink in. Yeah, circumference times central angle over 360. That gives you the arc length.
What's that circle looking thing called?
Circle looking thing. Oh, theta?
Yeah, thank you.
Here's a visual. Theta. Okay. So that 70 degrees is called a central angle, by the way. All right. Today we are not doing central angles. Well, not very much. We are doing inscribed angles. Oh boy. It's a big dot. So an inscribed angle, you guys remember inscribed meant like you draw inside a shape that's drawn inside something else. An inscribed angle has its vertex on the circle. So a central angle, its vertex is the center of the circle. An inscribed angle has a vertex on the circle. All right. How does this angle look like it compares to the central angle? Which one looks bigger? They look the same. No comment. This one opens this Y, this one opens this Y, they're not the same. This one, so notice I drew it so they intercepted the same arc. They both have the arc AB as their arc. But this angle, well, just think about it. If I was able to pick this up and drag the center and drag it over to the other side, what would happen to the angle?
It would shrink.
Yeah, it would shrink, right? Like this. Yeah, it gets smaller. So actually it's, does anybody want to guess? It's exactly half of the arc it intercepts. So both of these would be 35 because they intercept the 70-degree angle. So central angles are equal to their arcs. Inscribed angles are equal to half of their arc. So what's this angle? What's this angle? No? 90. It's half of its arc. So this is 180, the arc's 180. So this angle is going to be half of that. It's 90. So the moral of the story is if an inscribed angle intercepts a semicircle, it's got to be 90 degrees. See how it looks 90? Nice and pretty. I'm not 100% sure this is on today's, but I know it does come up later, so we'll go ahead and talk about it. Let me draw it like over here. And I did draw it very well. Okay, supposed to be a tangent line. That's pretty good. Alright, technically this is not an inscribed angle because one of the lines is outside the circle, but it turns out it still works like an inscribed angle because it's still going to equal half of this arc that it intercepts. So if this arc was like 100 degrees, this angle, that's ugly, would be 50 degrees. Does that make sense? Clear mud. So, kind of got to visualize. The 90-degree angle is intercepting this arc. So it's going to equal half of it. Central angle equals the arc, inscribed angle half the arc. This angle intercepts this arc. It's like an inscribed angle, so it's going to be half of 100 times 50. It just looks weird because one of the lines is tangent instead of like in the circle. Alright, what did I forget? If two inscribed angles intercept the same arc, that they have to be congruent. Oh, this one's important. I did forget something. What color do we want? If you draw in a quadrilateral, this angle and this angle. Okay, this angle over here. So I have an inscribed quadrilateral, some kind of like a rectangle, but whatever, doesn't matter. So this angle intercepts this arc, right? And this angle intercepts this arc. Lots of colors. So together they intercept, like this angle intercepts all the red, this angle intercepts all the green. So together, notice that makes the entire circle. So what does that mean? Well, together they have to equal half of, what's an entire circle? 360. So together this angle, I'll call it angle X, and angle Y, have to add up 20. They have to be supplementary. Or you could say the same thing about like these two angles, angle A and angle B. Together they intercept the entire circle, so they're equal to half the arcs. They should add up to 180. Okay, so if you have an inscribed quadrilateral, the opposite angles are supplementary. If you have an inscribed quadrilateral, the opposite angles add up to 180. Number one. What kind of angle is angle W? Not a trick question. Central. Number three. Find the measurement of angle W. If arc XY is 86 degrees. Alright, if arc XY is 86 degrees, what does angle W have to be? 86. A central angle is equal to the arc that it intercepts. Okay, but the second question on the same problem, it says find the measurement of angle Z down here in this corner. So what kind of angle is angle Z down here?
An inscribed.
Inscribed. So what's its relationship to the arc?
It's half.
Half. So it's going to be 43. Number 5, find the measurement of arc XY. So we're kind of going backwards. On 3, they gave us the arc and we said, so the angle must be this. This time we know the angle and we gotta say, so the arc is this. So it's the opposite. So, oh gosh. It's all connected, okay. So it says angle W is D. Right there. So the first question is find the measurement of arc XY. So if this is D degrees right here,
That's
what?
D degrees.
Yeah, this one's, the arc is D. And then what is the measurement of angle Z? D divided by 2. Yeah. You could say 1/2 D, or you could say D divided by 2. Same thing. One half times D equals D over 2. Okay, anyways, number 7. I probably should draw this to look like kind of an X. Does not go through the center. That times that. That's pretty good. 1, 2, 3, 4. So 1, 2, 3, and 4, those are all inscribed angles, right? There is no central angle drawn, so it does not go through the center. All right, it says angle 1 is 40 degrees. Let me go to blue or something. So if this is 40, the question is, what's arc AB? Gotta be down here. If this is 40, what's this? 80. Okay, so we're going backwards from before. Before we went from the arc to the inscribed angle, so we divided by 2. So now we're going from inscribed angle to the arc, so we multiply by 2. This is twice as big. So 80 degrees. I'm going to get rid of that 40 because they keep changing the numbers. Number 9. Arc AB is 130 degrees. Find the measurement of angle 2. Right. Angle 2 also hits this arc. Do you guys see it? So it is half of 130. 130 divided by 2, 65 degrees. Number 11. Okay, let's get rid of that guy. Wish I could throw. All right. If measurement of angle 3 is 47, okay, that guy. Find the measurement of arc DC. It's kind of like number 7. So this angle hits arc DC. So if this is 47, this is 47 times 2.
94.
94. Are you guys getting the visuals? I think sometimes people have trouble seeing it. Like, angle 47 is right here, and it's hitting this arc. So this arc is 47 times 2, twice the inscribed angle. Number 13. Okay, let's get rid of those guys. Okay, arc ADB. So it's a major arc going long ways around, it's more than half the circle, so it's got to be more than, oh, they tell us what it is, 290. Okay, so ADB, like all the way from here, all the way around is 290 degrees. Well, before I even read the question, what would this little arc that's left over have to be? 360 minus 290, yes. So that leaves 70 degrees for this guy. So the big arc all the way from there to there, 290, that leaves 70 for the little guy. They're probably going to ask about that. Find the measurement of angle 1. So angle 1 intercepts arc AB, just like back to number 7 again. So it's going to be half of this arc. 70 divided by 2. Is that the same answers? No. 35 degrees. Number 15. Assume this stone semicircle in Peru has a radius of 21 feet and that measurement of angle A is 5 degrees. Okay, I probably better draw that too. Semicircle, so half circle. That would be the center. The radius is 21 feet, so I'll just draw it. Well, let's see. A looks like it's is A right on the edge? Okay. Angle A. I think AD is supposed to be a radi. No, it's not. Angle A is 5 degrees. I'm not sure if this is if this is a diameter or not. I'm not sure what they're trying to draw there. So arc CD. All right. Well, doesn't really matter. If this is 5 degrees to D, what is this arc right here? 10. This is A. And what's the next question? Measurement of angle B. So angle B is like over here. Well, what's special about angle B? It's intercepting arc DC also. So what's angle B have to be? Same thing as angle A, 5 degrees. They have the same arc. They have to be the same. C. Estimate the length of the stone intercepted by the angles, finding the length of arc CD. So in other words, they want us to find the arc length of CD. How long is it from there to there? A little X there. All right, this actually is from yesterday. It's not the measurement anymore, not 10 degrees, but it's... What was the formula from yesterday for arc length? 2 radius pi theta times theta over 360. Okay, what's the radius? They told us it was 21. What's theta? We might get this. Well, is it 5 or 10? It's 10. Okay, 5 is the inscribed angle. We really want like this angle 10 degrees, or this arc angle 10 degrees. So yeah, we need 10 over 360. They probably put the answer in 2 forms. Yes, they did. So they put You don't have to do both of these, but 7 pi over 6 or 3.7 feet. Number 17. I'm going to draw this again. Looks kind of like a box. Maybe I made it too skinny. Well, that doesn't look quite right. Try again. Yeah, that's close enough. P is not on that point. I think they call this point Y. Where they cross at. Y is not a central angle. Or Y is not the center. P is the center. So anyway. MLN check. Alright. Ready to roll. Arc MLO is 212. Let's go to red. Okay. So MLO, that's all the way from there to there. 212 degrees, a little over half the circle. We are looking for angle MNO. MNO. Does this angle intercept this arc? Yes, it does. It's an MNO, so it's going to be half of 212. This is not a diameter. This, if it was, this would be 180. But it's bigger than 180, 212. So 212 divided by 2 should give us that guy. Now they do ask 2 questions on this one. The second question is, what is angle MLO? No, let's go green with this one. So MLO is right here. Talked about this at the beginning, but it's intercepting the rest of the circle, like from there to there. So, here, a couple ways you could think about it. If this is 212, well, how would I find this green arc? 360 minus 212, yes. So that would be like 148. And this inscribed angle opposite of this arc would have to be half of that, 148 divided by 2. Okay. Now I talked about a trick at the beginning, maybe you guys didn't pick it up, but does anybody know a faster way I could have done that? 2 inscribed angles. So if you have a inscribed quadrilateral, the opposite angles have to add up to 180. Because together they make half of 360. So I could have just done 180 minus that to get that. It's okay, it doesn't matter, we didn't need to. Oh, actually can I throw this away without screwing it up? I'm a professional, smartboard easy. Look at that, alright. 19, arc MLO is 240. Oh, I could have left that red thing in there. Okay, this time it's 240, it's a little bit bigger. Okay. Find angle MLO. Alright, it's kind of the same thing as what we just did. Angle MLO is right there. MLO. So it's going to be half of this arc.
So
360 minus 240 is 120. 120 divided by 2 60 degrees. You said that like you're surprised.
What?
Who whispered that? Is that Natalie?
I said this makes sense.
Oh, you. Okay. Yeah, well, some people do have trouble because the visually confusing, I guess. Number 21, arc ML is 98. So 98 right there. Arc NO is 86. They're going to try to fool us here. Find the measurement of angle MYN. MYN. Right there. Yeah, this is tricky. Any bright ideas?
Google.
Google.
I didn't say that. Natalie said
Oh, Google. Well, okay. So I had to look at it for a second myself, yeah.
Can you do 86 divided by 2 and then make it from that and never mind.
I mean, we are probably going to have to use these, right? Well, this angle that they're asking is in a larger triangle. You guys see the triangle? And see how the triangle, these two angles, this is not an inscribed angle. It's not a central angle either. So we don't have any, like, I don't know how it's related to this arc. But these two angles are inscribed angles. And angle M is going to be half of this. You guys see it?
Yeah.
So that's 43.
So I was
Angle N is half of that. So that's 49. Now if I know these two, how do I find that guy?
subtract from that.
Right, I have to add up to 180 in a triangle. So 180 minus 92 is,
88. So I kind of was on the right path.
well, you said the number divided by 2. Pretty far off, I'd say. But yeah, we did have to divide by 2. Number 23. Oh, gosh. I wish these were already made for me. I'll spend 2 minutes making a circle. But I know if I just say stuff, it'll be a lot more confusing. If I draw it, we might actually get it. Oh, this one they didn't draw us any. Let's just get that guy out of there. Alright. That's an ugly E.
No, she is. What? What do you mean? You say
I don't know why I drew that. Let's do that. D, E, F, G, H, J, K. JK? Question mark? Yes. And they gave us one angle right there. Is that it? 94 up here.
48.
Wait,
Down there.
49 down here.
And then 48 down there.
Gave us lots of stuff. I probably should have drawn those in blue. That would have been more helpful. Somebody's phone. About purple blue instead. Or indigo. That's what we talked about yesterday. Right. Now you're keeping me in mind. Okay, I give up. The question is, 5 minutes later, what is measure of angle D? Alright, do you guys see the arc that D hits?
Yeah.
It'd be whoop, right there from E to G. Okay. Problem is, I only know GF is 40. I don't know like all of this. So I need to figure out what this is right here. So how do I find EF? 31 times 2. This angle hits this arc, so EF would be twice 31, so 62. So arc EG,
So you add this together and then divide by 2.
right, is 110 if you put these together. So angle D is half of that guy. 55. Oh, this is like A, B, C, D, isn't it? Each of these is going to be worth 1 point, so don't. Gosh. It's taking a while. Yeah, maybe I'll be nice and let you guys work on this tomorrow. But am I nice?
Yeah.
Mm,
Tomorrow's Friday.
you did bribe me with a Jolly Rancher. You're holding that over my head.
There's also a blue one, which is one of the best.
Green apple.
I'll get you that one.
Get out. Cadence,
You're
get
fine.
out. Alright, DJE. This looks kind of like the couple problems ago. DJE, let's get rid of all these guys so I don't get confused. Oh wait, that's still there actually. Okay, DJE is right here. Okay, well actually let me keep this guy in here because that's not going to change. 55. So, do you guys see it? We just put that one in there from A. So, yeah, the three angles in a triangle have to add up to 180, I think. So 180 minus those two is 104, 74. Or, no, 104, 76. Just did 180 minus those two. Alright. HKJ. HKJ, right here. Well, I just said this was 76. I guess we have to use our past answers to find the new answers on this section. So if this is 76, what else do I know? If that's 76, what else is 76?
The other side, that one.
Vertical angles, right?
Yeah.
So, and then I got three angles in a triangle again. So 180 minus those two guys. These two make 107, so 180 minus 107 is... Using that picture for 22 also.
Yeah.
Okay, 25, angle Q, oh gosh, another picture. Lord deliver us. Let's see. Last picture though, I guess. We'll have to draw one more. Of course, in the other class, I should do it all over again. Alright. QRST. Kind of looks like a kite, but it's not.
It's like a lopsided.
Kind of. It's just sideways.
I didn't draw very well, but it doesn't matter that much. QRSTU. Oh, this one does go through the center though.
And then T is 70 or 40. 42.
Yeah, but you'd have to say angle RTS.
I know. I was just telling you so you would write it down.
I know. Okay, angle, we're ready to go. Angle QRS, so this guy plus angle QTS, this guy.
The whole thing.
Alright, so together, we kind of talked about this already. When you have an inscribed quadrilateral, like this angle up here hits the bottom, this angle right here hits the top, and together they hit everything. So what are they going to add up to? 180. Together they hit the entire circle, 360. So, but they're half of their parts, so they're half of 360. So yeah, it's 180. Probably the only time they'll ask that question. Okay, 27. Arc ST and SQT. So they're not giving us any numbers on this one, besides the 42, I guess. So arc ST. Okay, this one might fool us because we haven't used the trick yet. I did mention it at the beginning though. If this is 42 degrees right here, what does that tell me? That is 84. 42 times 2. Okay, anybody see where I'm going yet? What do I know about this big arc right here?
That equals 180.
Right. This time, that actually is a diameter. This actually does go through the center. So we know, unlike the other problems, this is 180. So if I need just this guy, it's 180 minus 84 is 96. And then the last of the Mohicans. Angles SQT. Right here. SQT, right there. Okay, I just found this to be 96. So what does that divide 96 by 2 to get the inscribed angle? That's the end. The end.
Here's the rest of it.
Yeah.
Yay. Hooray.
Oh, hold on, I got this. Caleb.